once again to my another tutorial, and in this tutorial I'm going to talk about the Android activity lifecycle. So in the previous chapter we were pretty much using always the on create this on create over like we were overriding these on create callbacks, right? So to display the layout of the UI of our screen, so we are pretty much using only this on create method to display our UI of the screen. So now we will explore in more detail about how the Android system interacts with your application to make this happen. Okay, as soon as the activity is launched, it goes through a series of steps to take, okay, series of steps like from a UI, like preparing the UI to be displayed, to be partially displayed, and finally it will also go through the series of steps like your activity UI being hidden, being backgrounded, and then finally being destroyed. Okay, so all this process, like all these steps from activity UI to be preparing to be displayed, being displayed, okay, being hidden, being backgrounded, and then finally being destroyed. This process is called activity lifecycle. Okay, so and for every one of these lifecycle steps there will be different callbacks associated with that particular lifecycle steps, or lifecycle that particular lifecycle stage, I should say. So you can use of that your activity, so you can perform particular action like overriding that method in this particular stage of the life cycle of the activity. You can customize your that stage on your choice. Okay, so understanding in detail about this life cycle. So and you can change the display or save the data when the app has been put into background, and then restore the data after your app comes in foreground. So you can make multiple changes on the basis of your choice, understanding the activity life cycle in detail. Okay, so before going through, let's understand about this override key. What is this override key provided by Kotlin? This means that either the function is providing an implementation of an interface or an abstract method, or in our case, it's pretty much it's like a subclass provided by the implementation of a overriding the parent class, right? It's like, you know, it's like pretty much this is a subclass, and it's pretty much overriding the implementation of provided by the parent class. Okay, so now let's not waste the time and let's understand pretty much all our lifecycle callbacks, the principal lifecycle callbacks that we will be working in our entire lifecycle like Android application development life stage. Okay, process. So first is on create, and on create this is the callback that we will be using the mostly for our activities to draw the full size screen. Okay, it is here where we will prepare our activity layout to be displayed. Okay, at this stage, after the method has completed, it is still not displayed to the user. Actually, it is not still displayed to the user, the UI. Okay, although if it will appear that the way it is displayed, but it is not still displayed if you don't because considering the case that if we don't implement any of these other callbacks, and we are implementing just this callback only, in this particular case the it seems that the UI is being displayed. Okay, but actually in this stage, okay, of activity lifecycle, you are just preparing the activity layout to be displayed. Okay, and all the other, if you don't implement all the other layout, that means it is automatically like implemented. So okay, so let me not confuse you guys, and let's go more further and we will understand in much in detail. Okay, so we will set up the UI of our activity by calling set content view. As you can see here, we set the content of view, like we set the layout associated with this activity, and carry out our initialization here. Okay, this method is only called once in your lifecycle unless the activity is created again. Okay, this happens by default for some activities, such as when you rotate your activity, then your in this stage your activity will be recreated. Okay, like from portrait to landscape orientation. Okay, and in this case also the save instance state is used to to save and restore the data. So actually, it is of data type bundle, which is like pretty much a map of key value pair optimized to save and retrieve restore data. So it can be also, as you can see, it's also nullable, being said that it can be also be null. That means whenever activity is created for the first time, then obviously it is null, and whenever it is recreated without recreated with the saved instance, then it is not null. Okay. Otherwise, if it is recreated without the saved instance, then it is null. Okay, in this case. Okay, so that is all about that, like on create callback. So now let's jump on to the another callback, which is called on start. So whenever the activity restarts, this is called immediately before on start. Okay, it is important to be clear about the difference between restarting an activity and recreating an activity. So when an activity is backgrounded by pressing the home button, okay, let me just explain you. Okay, let's run our activity. This is the simple activity. So when you press this this button, okay, this button, you just pretty much make your activity in background, you in background, right? So whenever also you press it, like you or review on home button, so whenever you press the home button, your activity is pretty much backgrounded, right? So actually there are three important physical buttons in our emulator that you can check. This is a back button, this is a home button, and this is a overview button. Okay, so we press the home button, and the activity is backgrounded. So what we have to do, we can press overview activity and click this to restore the activity, right? Like restore the activity from background to foreground. Okay, so when it comes in foreground, a callback which is created which is called on restart. Okay, so this is the purpose, I mean, this is where your activity stays lies here. Okay, it's called, I mean, like on restart is called in during this stage of life cycle of this activity. Okay. Okay, so activity when the okay, on in the case of restart, the activity will be not created. So that's the difference between restart and recreate. Okay, so here on restart, your activity is not created. Okay, so we will be going through in detail, okay, in this matter. So okay, let's go on through another callback, which is called on start. In this callback, the activity is brought in from the background to foreground. So whenever the activity was in background, and then it came to foreground, on this stage on start was also called. Okay, so so this the like on start called after you restart. On start will also be called to start your activity from coming from background to foreground. Okay, so okay, let's move forward. On restore instance state, we also have another callback which is called on restore instance state. So if the state has been saved during on save instance state, this is the method that is called, that the system calls after on start, when you retrieve the bundle state instead of restoring the state using on create. Pretty much when your method calls on start, it would be also on store instance state is also called by your application when coming from background to foreground. So upon completing the callback, the on like like when your system calls the on start, So this callback is called after on start. Okay, this is the first thing you have done. And then when you retrieve the, so like when you have restored data, then on restored like for example, if you have saved the data on the save instance state, then this you will also, after on start, you will also restore the instance state that you have saved when the app goes in background. Okay, and it will restore the instance state from the saved data, saved instance state. Okay, so this is what it will be doing. Okay, so now we will also have on resume. The on resume, this callback is run at the final stage of creating an activity for the first time, and also when the app has been backgrounded. Okay, so on resume is like kind of a final stage of creating an activity for the first time, and also when the app has been backgrounded and then brought into foreground. So on resume is also created whenever you go, activity goes in background, then it comes to foreground, you know, or activity goes in background, then you from the overview you just make the activity in foreground, right? So during all this process, all this life cycle will be created. So we will be checking by through code, via code, how which life cycle is created in which state. Okay, so I will be giving you a simple demo, but I want to just finish with the theoretical part here first. Okay, okay, so now on saved instance state, there is also another callback call on save instance state. Okay, during this on save instance stage, what so if you want to save the state of activity, the so you can save your instance state here. Okay, so you have to just pretty much add the key value pair using one of the convenience function depending on the data type, okay, you are using, and you can save the instance state here. Okay, so and finally you also have another callback call on pause. When your activity is being paused, you have also when activity starts to go in background, you activity goes in pause. On stop, when your activity is pretty much already has been backgrounded. Okay, the activity is already hidden, you know, so whenever you place this, the activity is hidden, it will show the pause and on stop is called simultaneously. And finally your activity will be destroyed. In this state, the system pretty much kills the activity. Right now our activity is still present, you know, if you go to the overview, our activity is still present in the background. But if I just press this and, like, you know, if I just swipe up, our activity will be destroyed and no more. So if you go back again, you see no recent items here, so our activity is not in the background, it's pretty much it's destroyed. Okay, so so this is how what is about the simple overview of how the activity lifecycle is working, is a theoretical description about what I'm saying. You can also go through my Medium blog spot where I've explained in detail about the activity lifecycle, you know, on create, the activities learn, on visible, activities starts being visible, you know, activity running in foregrounds, handle user inputs on resume, you know, activity is in background and it becomes paused, activity is not visible on stop, activity is destroyed completely or destroyed, or you can restart your activity and the activity is getting restarted again and activity is visible again, you know. So this is a pretty much simple life cycle, that explanation that I have gone through my tutorial, and I have also more coming here in my previous lecture. So yeah, I strongly suggest you to follow my blog here. Okay, and yeah, being said that, okay, let's now implement a simple application or simple uh, like uh, let's log all these activity callbacks. Okay, so we will create an application to log our activity lifecycle. So in order to understand it much in detail, okay, so So we will try to verify the order of the callbacks. Okay, so we will add a log statement, and in the end of each callback, and also we will provide a tag to this callback, I mean like to the logs, so that we will understand that this is coming from this particular activity. Okay, so uh, to define a tag, actually we can define it globally or locally. So constants in Kotlin are pretty much identified by a constant keyword and can be declared at a top level. So we can pretty much declare a constant in a top level, like my public constant, and we can provide a value. You can globally define a constant. Okay, okay, or you can define it locally privately, and Kotlin has provided top level constants generally used if they are required to be public, but we don't want to define a public top level constant. So for this purpose, like for providing a tag, we need a private constants, and Kotlin provides a convenient way to add a static functionality to classes by declaring a companion object. Okay, and we will provide a private constant value called tag, and our tag is a, sorry guys, const, and our tag is a main, not main activity, it's a life cycle, it's a demo activity, right? Okay, so it's the better way of declaring your tag as a public constant is this way, um, because it's pretty much private to that class, right? And now we will start adding the log statement to the end of each callback methods. Okay, so we'll pretty much provide a debug statement on create. Okay, so we create on create tag, we added the on create tag, and okay, so now I will try to understand what is this logcat. Okay, and as you can see that this log statements can be this is a log class provided by Android. Okay, Android library, as you can see here, testing your Android. Okay, we can have a log type of different types, like verbose, debug, info, warning, error, and assert. Okay, like I'll be going through in detail. So but first what I want to do is I want to pretty much run the application, go to my what I have to do is I have to go to my uh, go to my logcat, right? So where is my logcat? My logcat is pretty much present here, and I will choose my emulator, and I will see my logs. I will see all my logs here. Okay, so at the first glance it will be pretty difficult to understand what is your where is your log, right? So okay, divide, let's understand our log statement in detail. Okay, so what is uh, okay, so let's understand it in detail, but first of all let's understand the logs. Okay, uh, let's understand the logs. Okay, so there are different types of log, right? We have log which is verbose, which provides us verbose messages, that is everything, every messages. We have debug messages, we have info messages, we have warning messages, we have error messages, and also we have what the fuck WTF messages. It's what a terrible failure messages. also called WTF or what the fuck, sorry to say that. And mm, yeah, we will be going through all this. Okay, let me actually mm, provide you all the different types of. So we have a, okay, let me explain it. Verbose message. Okay, what I was talking about is we have verbose, we have debug, we have information, locket, info message, we have uh, warning messages, and we have also error messages, and we have finally the WTF. What I was saying is it seems like what the fuck, but it's not. It's like a it means what a terrible failure message. So these are the 6 different log levels that can be used to output the message information from the least to most important. So this is the least important. Sorry for this one. It's explanation. Okay, this is the explanation. So what I am trying to explain is we have 6 different log levels that can be used to output message information from least to most important. So this is the least important and this is the most important message. Okay, I mean, and the last log level highlights an exception that should never occur. So this means that the exception should never occur, so this is the thing that you have to understand. Okay, so this is the of high priority messages because this is an error, and this is a low priority message because this is a verbose messages. All right, so as I told you, we go to the logcat, then we will try to display all the log messages. Okay, and then we will try to examine the logcat window output and see the log statements that we have added formatted like the line below. So okay, let me run it again. And actually, you can clean the log, and you can, yeah, so actually, you can clean your logs and you can run it again. So you see, now we have this we recently created this all this on create, on verbose, verbose message, debug message, info, warning, error messages, and what a terrible failure messages. So these are is what are the log levels that I was explaining here before, because I'm logging these messages, right? So for the moment I just want to remove these log messages. I want to remove the explanation, and I want to clean this and just apply it again. So now we have just this on create, as I can see here. Okay, and so actually at first glance it looks very difficult, right, to understand at a first glance, like the log statements look quite difficult to understand. Okay, so let's break down the following statement into separate pairs. Okay, let's break down. So let's please let's look only at our one of the log statement, and let's look at this one, for example. So what this the first block is a date. Okay, it's date of today, and the second block is the time. The third block is the process or thread identifier. The fifth statement is the class name, and the next statement and next block is like a package name. And finally we have the log level here, which is debug, verbose, edit, or uh, information or warning or whatever it is. This is a log level, and finally we have a log message. Okay, so this is now I think it is much better to understand, right? So let me close it again. And now by default in the log filter, we will see that your package is mine in your log. So we can examine the outputs of the different log of all the process on the device by changing the log filter here. So this is a filter here, so you can pretty much assign whatever filter that you want, like like this is okay. So let's apply our filter here to debug. Okay, and let me apply the messages here again. And so what we have to do, we can also what was the purpose of us creating the tag is because we want to filter the log messages by tags. So the tag is pretty much I want to tag is a lifecycle demo activity, and you see we have only the associated log messages with this particular tag, right? So this is the tag. And yes, we have pretty much we are successful to create the logs, and now let's assign the log to each of our method. So like this is on restart, and now we will try to understand on start. Okay, and okay, so I'm just pretty much adding log to each of the callback methods. Okay, voila. And now let me apply the applications again. So when we apply the everything was pretty much created, right? Recreated. So that's why on create was called, and on create was also called the second time right here. Okay, so let me cancel this. Okay, so okay, let me cancel my application. Okay, close my application, like destroy my application. Let me run the application again, and let me go to my logcat, and let me see what are the callbacks that was called when I first launched my application. I was getting these two callbacks is on create and on start. Actually I missed one of the callback, guys, and that was on resume. Okay, let me kill my application. Let me run it again. Let me go to my logcat. Now you see. Okay, let me cancel this, guys, because I see that there is a it was written there twice. Okay, let me run my application. Okay, so yeah, here I was what I was trying to explain you, and where I was trying to arrive is this one. So whenever you destroy your application, when you create it, like when you fresh install your application, these three callbacks are important. That is on create, on start, and on resume. If you remember, I was telling you guys that on create is just the starting point, like initialization phase of your application, where you initialize your view. But the real view, when the view gets displayed, is after on resume, right? After you on start and on resume. So these are also some hidden callbacks that pretty much doing something in the background, like in the sense, like your view start really as you will really see the view after on resume. Okay, so on create is just the initialization phase, okay, of the view. But if you don't implement all this method, it doesn't mean that you don't see the view, because it's all you are pretty much making like, you know, super on restart, because you are just implementing your super, I mean like your parent, what the parent implementation is already done here, right? Super on start, that means you are implementing whatever it's of parent, like just implement it as it is, you know, you don't make any changes. But if you remove this and make some changes, then these changes will appear. Okay, so this is the main understanding point of your life cycle. And okay, so yeah, so these three callbacks were there after you freshly start your application. And then let's try to let's try to click to the home. And you see, when you click home, your application goes in background, and when the application goes in background, these two callbacks, on pause and on stop, is called. So you first on pause and then you on stop, right? And what else? Let's cancel this. Okay, when I go back to my overview and I want to I want to make my application from background to foreground, you see that three callbacks will be called. That is on restart, on restart, on start, and on resume. You know. So finally, on resume is the point where you actually see your view, right? And same goes at this, you know, if you press this like home button, you will call on pause and on stop. And when I bring my application from background to foreground, I will also again call on restart, on start, and on resume. And finally, if I swipe this up and destroy my application, you see that application is destroyed. uh, okay, and let me see once again, guys. On destroyed is pretty much not called, because obviously you see that it's already destroyed. So after the destruction, this lock is never being called, right? So okay, let me add the log here above. Yeah, so now you can see the on destroy, because you see that on super you should just add it above the super to make also be displayed for on destroy. Okay, so that's the case, guys. And I hope I have explained enough for this discussion uh, about like about about the activity life cycle. So I hope that's it, guys. Okay, so yeah, there is also one another important concept that I want to tell you guys is about the orientation. Okay, so when the orientation change. Okay, so if you want to change your orientation, right, just please yeah, just first make your settings to auto rotate on. Okay, in your emulator, then finally you can rotate. Okay, let's rotate it. You see, when you rotate, on pause, on stop, on destroy, and on create is called again. So that means your activity is recreated, and on start and on resume, you know. And similarly, if I move it more, uh, okay, okay, let me go to my locket. Okay, sorry guys. Okay, let's understand it much better. Okay, so let's cancel everything. Okay, we are in this first state. Okay, we rotate. You see, on pause, on stop, on destroy, you destroy your activity and you create your activity again, you know. You recreate your activity. Okay, so this is the important thing that you have to. So whenever you change your orientation, you recreate your activity, and again, like, but still it's the same activity. Know why it's not changing the view? Okay, as you can see here, whenever you change the view, like when the it's like it's recreated. When you change your orientation, it's recreated pretty much. Okay, so this is the concept that you have to understand. And you can also have another callback call on configuration changed. Okay, here pretty much you can just log. So here this callback actually pretty much can just intercept the configuration change, right? So okay, let me change here. Let me put the locket. Yeah, but I cannot intercept this configuration change. It's pretty because, like, you know, there are some kind of I have a super there. So let me apply it again. Yeah, because I didn't apply it. Okay, let me do it again, guys. Okay, let me. Okay, so let me change the configuration. Okay, let me check one of the interesting concept here is Okay, so for this thing to work, actually you have to add config changes to your manifest. Okay, so orientation, screen size, or uh, screen layout. So if we do add this particular uh, code in your Android manifest with your activity that you are just working with. Okay, so now okay, let's pretty much cancel this. Okay, now you see that you have on configuration changed. It's pretty much working here. On configuration change is pretty being like called here, right? So this is also another interesting concept that you have learned here. And yeah, finally I think I have explained enough for this activity life cycle, and hope you like it, guys. It was pretty much lengthy, but it was more about explaining and going through all the important concepts, right? And thank you very much, and catch you again in the next lecture. Thank you.